Welcome. In this session, we'll continue to explore steepest descent method. And what we'll do in this session is we'll alter it. What we'll do is called scaling the variables. And this is a manual process that's usually performed by the user. So the idea, let's refer to the function that we had in the previous session. What we can do is we can observe that in the gradient of that function, the W1 term is about 10 times the W2 term. And we might suspect that that is one part of the oscillation and one part of the slow process. So what we can do is we can change variables. And a change of variables is something that we're familiar with from our long ago prerequisite calculus. And what we can do is we can say, we can go from the W we had, and then let's say that we're going to use a different set V. So we'll go from W to V. And the way that we can do this is we can say, well, W1, what we'll do is that will be 0.1 times V1, and W2 we'll just leave as V2. And what this will do is this will manually adjust the gradient. So what we have is that W is some symmetric positive definite matrix, and we'll call it M for manual, times V. And specifically, what we have is this relationship put into this form is the manually selected matrix would be 0.1001. So this is a symmetric positive definite matrix. And our iteration then becomes, we'll say that our k plus 1 estimate of the minimizer is our kth estimate of the minimizer minus a step in k. If we're looking at a fixed step size, that will be fine. And if we're looking at a backtracking, that will be variable, times the matrix B times the gradient of the function evaluated at estimate k transposed, so it goes from being a one form to being a vector. Let's see what this looks like. Here, what we've done is we manually selected the scale, and let's suppose we also manually select the step size. What we see is that this will rapidly find the valley, and then it will eventually find the minimizer. The valley still takes about 100 steps. What we note is that this is not a steepest descent. If you recall from the previous one, a steepest descent would be normal or orthogonal to a contour line, and that would take us over here, and then we would proceed downward in our steps. Instead, what's happening is that that B matrix is taking that steepest descent and altering it, in this case, towards the minimizer, and we're getting a faster approach into the valley. However, it's still imperfect. There are still some problems, and these problems have to do with this conditioning of the variables.